In this video, you're going to make your very first request to the Weather API. And we're going to do this in a static way at first, meaning that it's not going to use the actual latitude and longitude for the address you passed in. We'll simply have a static URL, we'll make the request, and we'll explore what data we get back in the body. Now, before we can add anything to Atom, I want to go ahead and explore this API so we can see how it works in the browser. This is going to give us a better idea about what weather data we get back when we pass a latitude and longitude to the API. To do this, we're going to head over to the browser and we're going to visit a couple of URLs. First up, let's go to forecast.io. Forecast.io is a regular weather website. You type in your location and you get all the weather information you'd expect. There's warnings, there's radar, there's the current weather, and we have a weekly forecast down below. This is similar to weather.com, but the one cool thing about forecast.io is that the API that powers this website, it's actually available to you as a developer. You can make a request to a URL and you can fetch the exact same weather information. That is exactly what we're going to do, and we can explore the API by going to developer.forecast.io. Here, we can sign up for a free developer account in order to get started making those weather requests. The Dark Sky Forecast API, it gives you 1,000 free requests a day, and I do not see us going over that limit. After the 1,000 requests, each costs a 1/1000th of a penny, so you get 1,000 requests for every penny you spend. We're never going to go over that limit, so don't even worry about it. There is no credit card required to get started. You'll simply get cut off after you make 1,000 requests. To get started, you're going to need to register for a free account. It's really simple. You just need an email and a password. I already have an account, so I'm going to log in. Take a moment to keep watching the video while I pull up the dashboard. Now I'd like you to pause the video, go back and register for your account. And when you get to this screen, once you have your account created and you're logged in, you can go ahead and click play and we'll pick up where we left off. Take a moment to pause the video. When you're done, click play. All right, I'm going to assume that you've created an account and that you're looking at the dashboard that I see. The only piece of information we need from this page is our API key. The API key is like a password. It's going to be part of the URL we request, and it's going to help forecast.io keep track of how many requests we make a day. You can see I've used 10 of my requests. I still have 990 left for today, which is fantastic. Now I'm going to take this API key and paste it inside of Atom so I have it accessible a little later on. Excellent. The next thing we're going to do is explore the documentation, the actual URL structure we need to provide in order to fetch the weather for a given latitude and longitude. We can get that by scrolling up to the top and going to the API docs link. Here we have a URL. This URL is exactly what we need to make a request to in order to fetch the data. Before we add this URL into our app and use the request library, I simply want to copy it and paste it into a new tab. I'm not going to hit enter just yet, because we do need to swap out some of this information. For example, we have our API key, that needs to get replaced. We also have latitude and longitude, both of those need to get replaced with real data. Let's get started with that API key first, since we already copy and pasted it inside of Atom. I'm going to grab the API key, copy it, and replace the letters API key with the actual value. Next up, I can grab a set of longitude and latitude coordinates. I'm going to do that over inside of the terminal by running our app. Node, app.js, and for the address, I'm going to use my zip 19146. Go ahead and use your current location so you can fetch the latitude and longitude coordinates. Next up, I'm going to start copying these over into the URL where they belong. The latitude goes between the / and the comma. Next up is the longitude, and that is going to go after the comma. -75 with a bunch of nines sits right here. Once you have a real URL with all of those three pieces of info swapped out for actual info, you can make the request, and what you're going to get back is the forecast information. Now remember, I'm using JSON View, which is why mine might look a little different from yours. I highly recommend installing it. Now the data we get back, it is overwhelming. If you start scrolling down, there's essentially an infinite amount of data. We have a forecast by the minute, we have forecasts by the hour, by the week, by the day, all sorts of information. It's really useful, but it's also super overwhelming. In this section, we're just going to be using this first object, currently. This stores all of the current weather information, things like the current summary, which is clear, the temperature, the precipitation probability, the humidity. A lot of really useful information is sitting right in here. In this case, what we really care about is the temperature. The current temperature in Philadelphia this morning is 84.95 degrees. It's going to get up to 100, so it's definitely going to be a hot one. It already feels like 90. This is the kind of information we want to use inside of our application when someone searches for the weather in a given location. Now, in order to play around with this, we're going to take this exact same URL, a static URL, and we're going to make a request over in app.js. And that's actually going to be your challenge for the video. What I want you to do first is do a little setup work. Inside of app.js, I'm going to comment out everything we have so far. And what you're going to do down below our API key is make a call to requesting this exact URL, just like we did for the geocode API in the beginning before we made it dynamic. Then you're going to print out the body.currently.temperature property to the screen. So when I run the app, I'll see the current temperature for whatever latitude and longitude I used. In this case, it's a static latitude and longitude representing Philadelphia. So take a moment to import request in this file, make the request, and print the current temperature to the screen. Once you have that temperature printing, test it, make sure it actually prints, make sure the number looks right, and then you can go ahead and click play. All right, how'd you do? Hopefully you were able to make the request and get the temperature showing up to the screen. In order to get started, I'm going to load in request. Now we had it in this file before and then we removed it, but we're going to add it back once again. I'm going to add it right here by creating a const called request and loading it in. Const request equals require request. Perfect. Now we can go ahead and make the actual request just like we did for the geocode API by calling request. It's a function just like this. We have to pass in our two arguments, which you needed to add for the challenge. The options object is the first one, and the second one is the arrow function. This is our callback function that gets fired once the HTTP request finishes. Before we fill out the actual function, I want to go ahead and set up our options. There's two, URL and JSON. I'm going to set URL equal to a static string. The exact URL we have over in the browser, I'm going to copy it and paste it right inside of quotes. Then on the next line, after my comma, I can go ahead and set JSON equal to true, telling the request library to go ahead and parse that body as JSON, which it is. From here, we can go ahead and add our callback arguments, error, response, and body. These are the exact same three arguments we have over here for the geocoding request. Now that you had this in place, the last thing you needed to do was print the current temperature, which is available on the body using console.log. I'm going to use console.log to print body.currently.temperature. Excellent. Now that I have the temperature printing, I need to test it by running it from the terminal. From the terminal, I'm going to rerun the previous command. The address is not actually being used here since we commented out that code. And what I get is 85.27 perfect. Now 85.27 is different from what we got over in the browser. We have 84.95, but it is the morning here and the temperature is skyrocketing as the sun starts coming up. Here you can see it's already gone up a fraction of a percent since I ran that previous request. Everything looks fantastic. We have our weather API call working inside of the application. Now in the next few videos, we're going to start putting this together. We're going to add our request inside of the callback for geocode address. This is going to let us take that dynamic set of latitude and longitude coordinates, the lat long for the address used in the arguments list, and fetch the weather for that location. That is going to create a dynamic weather application as opposed to the static one we have right now. Before we wrap this video up, I do want to add a little error handling inside of our callback function. We're going to handle errors on the error object, and we'll also handle errors that come back from the forecast.io servers. First up, just like we did for the geocode API, we're going to check if error exists. If it does, that means that we were unable to connect to the servers, so we can print a message that relays that message to the user. Console.log, something like unable to connect to forecast.io servers. Excellent. Now that we've handled general errors, we can move on to a specific error that the forecast.io API throws. This happens when the format of the URL, the latitude and longitude, is not correct. For example, if I go ahead and I delete some numbers, including the comma, and I hit enter, we're going to get a 400 back, a bad request. This is the actual HTTP status code. This is Andrew with a quick update. The status code you should see now is a 404, not a 400. I'm going to address that in just a minute when we implement this into our code. If you remember from the geolocation API, we had a body.status property that was either OK or 0 results. This is similar to that property, only this uses the HTTP mechanisms instead of some sort of custom solution that Google used. In our case, we're going to want to check if the status code is 400. Now, if we have a bad API key, I'm going to go ahead and add a couple E's right here. We're also going to get a 400, so both of these errors can be handled using the same code. Back inside of Atom, we can handle this by checking the status code property. After our if statement, closing curly brace, I'm going to add else if response dot status code. This is the property we looked at when we looked at the response argument in detail. Response.status code is going to be equal to 400 if something went wrong, and that's exactly what we're going to check for here. If the status code is 400, we're going to print a message, console.log, unable to fetch weather. Awesome. Now we've handled those two errors, and we can move on to the success case. Else if response.status code equals 200. The status code is going to equal 200 if everything went well. In that case, we're going to print the current temperature to the screen. I'm going to cut this line out and paste it inside of the code block. Awesome. Andrew back again to finish off that update I alluded to earlier. What I have here is an updated code snippet, and you can actually replace everything we have in the current callback function with this code. Now the condition checks if there is no error and the response status code is a 200. If that's the case, what do? We simply print the temperature like we were doing last time. That was in the else if clause at the very bottom. Now we have an else case here. So if there is an error or the status code is not a 200, we're going to go ahead and print this message to the screen. This is going to handle things like the server not having a network connection or 404s from an invalid or broken URL. All right, use this code instead and everything should be working as expected with the latest version of the Weather API. Now we have some error handling in place and we can go ahead and test that our app still works. From the terminal, I'm going to rerun the previous command, and I still get a temperature 85.28. Back inside of Atom, I'm going to go ahead and trash some of the data by removing the comma, saving the file, and rerunning it from the terminal. This time, we would expect unable to fetch weather to print to the screen. And when I rerun the app, that is exactly what we get. Everything looks great. I'm going to add the comma back in and test our last part of the code. Right here, we have if error. I can test that by removing something like the dot from forecast.io. I can rerun the app and I see unable to connect to the forecast.io server. All of our error handling works great, and if there is no errors, the proper temperature prints to the screen, which is fantastic. And that is it for this video. We now have a way to fetch the weather based off of that latitude-longitude combination. In the next video, we're going to start integrating this into our app using the latitude and longitude that comes back from the geocode API. I am super excited to continue on, so stay tuned. I will see you next time.